All right. So let's do a quick roll call and see who all are here. So we have Adya, we have Milana, we have Hiranya, we have Dikshita, Laksh, Myra, Nihan, Sami, Urvi, Saurya, Abhi, Suhina, Arihan and Vasundhara. Wonderful. In the classroom we have some kids, Advik, Arav, Tasvik, Adya and one disappearing kid who comes and disappears, disappears. Okay, alright, I'm just kidding. So let's think about what we are going to learn today. And we are starting with the topic called probability.
Yeah.
So we'll probably learn something today. And that is the probability of learning something. What do we mean by probability? Okay, Adam, it looks like there's a football match starting now and the key striker of the team was missing, and as soon as you saw the striker, yay, our team is complete now, you start dancing. Right? That's how you're behaving? Okay, let's not do that. We're not going to have a football team, we're not going to do any touchdown right now. Yes, Sami. Adam?
So probability is like
Focus on something which is more meaningful. Yeah. Come, I have seen your hand, I'll come to you. Yeah, Sami. Go ahead.
probability is like the name. It's how probable you are to pick something. Like for example, it's like in a bag you have like 4 black marbles, 5 yellow marbles, 3 blue marbles, something like that. And they'll say what's the probability of picking a black marble?
Okay. I'll come to you guys also. Saurya, give me a simple definition. So Lakshya and Adya, we are talking about probability. And that's a very relevant topic. What is the probability of me being able to teach you guys? And that depends on how much attention you are paying to what I'm saying. So let's listen to this conversation and participate in that conversation as well. Yep. Yes, Saurya, go ahead.
So probability is just the chances. What are the chances of something happening?
Mm-hmm. Yep. Abhi,
I was about to say that.
same thing. He borrowed your idea. How about Laksh?
What were you saying?
I was asking, what is your understanding of probability?
Probability is like the chances of something happening and
Okay.
something of not happening.
Okay. Advik.
Yes.
Chance. Probability is a chance. Yeah. He took your. So the probability is a chance, and since the chance was taken by somebody else, it became a dance. Angry dance. Let's not do that. Come back to Dikshita. Yeah, Dikshita, you're saying something.
Oh, I was about to say that it's a guess or a chance.
Guess or a chance. So now, everybody here, Tasvik, here, no matter how much you stare your notebook, the idea is going to come on the board. Okay. It's not going to transmit everything I write here straight to your notebook. So you have to pay attention to the board, okay? Alright. Aryahi, can you see me better?
Yeah.
Okay. If there's a problem, you can find a chair and move to this side also, okay? Okay, guys. I know you guys are good friends in the school, but right now in the classroom, it's only you and the teacher, nobody else. That's how you have to pretend. Now, probability, as you guys rightly defined or described, probability is nothing but a chance. Probability, as it means in terms of English, what is the possibility of something happening? Now, the entire math revolves around comparison. Okay? If I say 4 and 5, I'll not say 6 and 7, okay? I will not say that. Though that is the most annoying number that I've come across in last 1 month. Okay? So if you're talking about 4 and 5, these are two numbers. 4 and 5 are two numbers. Let's stay constructive, okay? If we're talking about 4 and 5, 4 is a number, obviously. 5 is also a number. And it just tells you that one is bigger, one is smaller. 5 is bigger than 4, 4 is smaller than 5. That's how we'll read it. Everything. Tomorrow if you learn about a number called 1 trillion, what it says is this is bigger than every number up to 999 billion, 999 million, 999,000, 999. So it is greater than any number which is 999 billion, 999 million, 999,000, 999 as a number. Any number bigger than this, so it's a comparison. So what I'm trying to iterate here is that if you are talking about any concept, even probability, it's a comparative, it's a comparative scale. You're comparing that against something. Now let's look at it. Let's look at what I'm saying and how I can make some sense out of it. If you are talking about probability, let's say you all went for a test. Okay? You appeared for a test for 100 marks. Happy? Happy? Very happy? Why you have to do something that you're not supposed to do? No, whether you do this like Pushpa, or you do this, or you say number 6 and 7, all that is not needed in this class. You're talking to somebody who is a middle-aged person only trying to teach you math. There's nothing else I know or want to know about right now. Okay? So pay attention to the book. Now coming back to probability. I'm talking about what is the probability? How do we relate to it? You all went for a test. It was for 100 marks. What is the best possibility that you can think of? Can somebody get 110? It's a test for 100 marks. How would you get 110? You are tweaking like the way your teacher was tweaking probably.
There's a 0% chance.
Yeah? So basically the best you can get is 100. Somebody will get 99, somebody will get 98, somebody might get 0 also. Okay? So what I'm trying to say is all these are probability or possibility of what could happen. And you are comparing it against the base of 100. Same way, if you look at probability, it says, let's look at the basic definition of probability. Probability says anything's probability is chance of that event against total number of events, number of possible events. This is how you define probability mathematically. Now let's look at a simplest possible scenario of tossing a coin. I said tossing a coin, somebody tossed. Okay. Wait, I'm just teaching right now. We are not debating right now. So probability means, in mathematical terms, a chance of any particular event divided by total number of events that you are trying to compare against. So this is a relative term again. Now let's look at a situation when I'm tossing a coin. So when you toss a coin, let's imagine you're talking about a fair coin where there's no behind the scene activity happening. Chance of that any event. Okay? Don't go by my writing. You have everything on the video anyway. Don't worry about it. So probability says probability of any event is chance of a number of occurrence of that event divided by total number of events. Now let's look at a coin. I'm tossing a coin. I can get a head or I can get a tail. Yeah? Okay.
Wait, what is
I didn't know that I have got such a great sense of humor. My math also sounds funny at times.
Wait, what if it's that one movie?
What is that?
What if it's that one movie?
Let's talk about things which are relevant. So I can get a head. So let's look at a possibility or probability of head. I'm talking about probability of head. If I'm tossing it, I can get either head or tail. But so there are total two possibilities. One is head and one is tail. So here total number of possible events is 2. I can get a head or I can get a tail. But we are looking at probability of head. So that is only one event. Out of 2, head I can get is only 1. So that is how the probability of getting a head or a tail is 1 out of 2. Now it doesn't mean that every time if I toss the coin twice, I'll get one head and one tail. There is no prediction that you can make. It says that this is derived. Let's say you should toss it for more number of times. It's like an experiment. You toss the coin 2 times, your head or tail might go a little misleading. You might get a both head or both tail also. That's possible. But if you toss your coin, let's say 10,000 times, and then you take the average, you will say that half the times you are getting a tail, half the times you are getting head. If you toss it maybe 1,000,000 times, if you are utterly jobless and just doing the tossing of coin the whole day, yeah? Ask yourself once if the question that you are asking is relevant or not. If not, that should not come to me. Okay? So, Advik, you have other problems to deal with. Let him worry about his problem. I have given him the message that he needs to get. I don't want everybody to poke their nose into everything. But what I'm saying is, this, look, Gayatri joined, Urvi is there since beginning. Okay, yeah, I was just checking if somebody joined. But what I'm saying is, probability, there are 2 things that I've said so far. One is, probability is coming from English, which says, probability is nothing but a chance. How do you define that chance mathematically? This is the definition, which says, if you're talking about probability of any event, the probability mathematically you can say is probability of that event divided by total number of possible events. Okay? Is that sounding okay to everybody, or I'm getting you guys confused? Now, the way you will relate that is, it's not that, okay, it just tells you that this is the law of averages. Meaning, if you do the same activity 100 times, 200 times, 500 times, 1,000 times, 10,000 times, 20,000 times, then you look at the average, you will see the same thing. So here, if I'm talking about tossing a coin, or I can get a head or I can get a tail. So there are 2 events total. Probability of getting a head is 1 out of 2. Probability of getting a tail is also 1 out of 2. But it's not that, okay, first time I toss, I'll get a head. Next time I toss, I'll get a tail. No, there's no guarantee like that. It's a fair coin, anything can happen. Nobody can predict it. Otherwise, everybody would have been a millionaire by doing gambling. Yes.
Like, what if it's like, can there be like different probabilities of events? Like if you have like 5 red marbles and 20 like black
So we'll come to that. Right now we have just touched the tip of the iceberg. We have not gone that far. Okay, I'm just scratching the surface over and over again so that it creates a. See, there are 2 kids who are super busy right now. One kid is drawing my picture, and one kid is staring him to see how interesting that picture is. I will not say the names. Kids who are supposed to get the message, they have got the message. So let's focus on it. Yes, Laksh, go ahead.
Sir, you're talking about the experimental probabilities because there's also the theoretical probabilities.
So you guys are probably 3 steps ahead of me right now. I'm still scratching the surface to make sure that everybody clearly and thoroughly understand what probability is. And then we'll go deeper into it. Okay?
Okay.
Now, this was one probability that we talked about. Now let's go a little further. Probability is not just about tossing coin. If that was the case, everybody would have got a distinction in math. Right? So let's look at next scenario. And we'll again relate back to the same concept. Let's say we are playing with snake and ladder. Okay? Everybody would have played with snake and ladder, right? I mean, sometimes when I'm teaching, I'm talking about snake and ladder, I say snacks and ladder. So, no, it's not snacks, it's snake and ladder. Okay? So, if I say snake or versus snacks, it is only because of a slip of tongue. Don't get me wrong. Okay? Coming back to this one. So, here, it's a dice that we are rolling. It has 1, 2, 3, 4, 5, 6, up to 6 written on it, right? I'm assuming everybody has seen a dice and I don't have to go into detail of it. If somebody says, find out what is the probability of getting a number more than 3. Pen and paper. No airy math. I don't believe in airy math. What is the probability of getting a number more than 3? I am rolling a dice once. What is the probability of getting a number more than 3? Yeah, how much is that? Tell me. You were so much in a hurry to tell that. Huh?
50%.
Give me a more simplistic answer. I am not very good with math. Huh? Go one level further. Okay. I'll come back to you. Okay. Let me not. Yeah, you tell me. What is the probability of getting a number more than 3?
3 by 6.
Did you work in any Indian serial before? One actor will make a dialogue and everybody will start turning this way. Right? Really, 3 times. That's what you're doing right now. Yes, Sammy.
Oh, sorry, so my hand is just up
Okay.
to the last.
Yeah, Lach.
The chances of rolling a dice with a higher number than 3 is 3/6, which is simplified to 1/2.
Okay.
Because you have 3 numbers that are not the requirements that you want 1, 2, and 3, but there's a requirement that you do want.
No. Let's keep our answer confined to what I asked. I said, what is the possibility of getting a number more than 3? So what would be your answer? Yes, Sohina, go ahead.
It's gonna be 4 to 6.
No, one more time. 4 to 6. What is the probability in mathematical terms? How do you represent that?
In mathematical terms, it's going to be possibility is going to be 3 times 4 to 6.
Okay. I'll come back to you. Okay. Yeah. Go ahead. Arihan.
I got 1/2.
1/2. Okay. Dikshita.
I got 1/2 too, sir.
Okay.
1/2
Okay.
50%.
Okay. Last year. 1/2. How?
Because 3 and 6 is like a half.
Okay. So look at the question. Okay. I said, what is the probability of getting a number more than 3? What are the things that we can get when I'm rolling a? Okay, it's okay. Let the teacher do his job. Yeah. Let the teacher do his job. Okay. So I am rolling a dice where I have numbers 1, 2, 3, 4, 5, and 6. So I can get one of these numbers only. So these are total number of events. 1 to 6. Yeah, Dikshita, you're saying something?
No, sir, it was from the back.
Okay. So this is the total number of events. Now we're talking about what is the possibility or probability of getting a number more than 3? 4, 5, and 6. Now look at it. What is the probability of getting a 1? You guys rushed for the answer and everybody got the right answer, but what is the probability of getting a 1?
1 by 6.
It is, probability of getting a 1 is 1 over total number of events. So 1 is only one event. Total events is 6. Out of there is a dance in northern part of India called Bhangra. Okay. I will remind you once, twice, thrice, 4, 5 times, and then you're still not doing it. Eventually, I'll run out of my patience and I'll start doing Bhangra in the class.
No, these are niche events.
Yeah. Yeah. So, I mean, what I'm trying to say is, why to get into a direction that is not needed? We are already halfway through the class.
We are.
Let's make best use of the time that we have to learn what we are here for. Correct? So here we are talking about what is the probability of getting a number more than 3. You guys gave me a very simple answer. Okay, what is the probability of getting a number greater than 3? So we are talking about 1, 2, and 3 events. 3 out of total number of events. 1, 2, 3, 4, 5, 6. 6. This is 1 by 2. And that is spot on. That is correct. I'm telling you guys, this is another way you can look at it. And again, this will come out to be handy for us when we are dealing with more interesting probability problems. When we are talking about what is the probability of getting number more than 3, I'm talking about probability of getting 4, probability of getting 5, probability of getting 6. So, what is probability of getting 4? 1 by 6. What is probability of getting 5? 1 by 6, like any other number. What is probability of getting 6? Is 1 by 6. So, if I'm talking about probability of getting number greater than 3, I'm talking about adding this probability, and this probability. So, that is another way of looking at it. When you are talking about scenario, when you have multiple events happening, if you want to derive the probability of a sum of events, you can break it down and add them together. Yes, Gayatri.
So does it always need to be the simplified form?
I mean, see, when you say that, okay, my probability here in this scenario for this question is 3 over 6, there's no harm in that. 3 over 6 is fine. If you want to simplify that and say it's 1 by 2, that is also fine. If you say my probability is 0.5, that is also okay. If you want to convert that to a fraction and say 1 by 2 is nothing but 50%, convert to percentage, 50%, that is also okay. So you can
put it in any of those forms.
You can put it in any form, yeah. As long as you are calling it out with the right terminology, it's fine. You can say my probability is 50%. Yeah? Or you can say my probability is 1 by 2. Or my probability is 3 by 6. All are fine. But what I was kind of emphasizing on by doing all this circus on the left side of the board was that you can look at this in a comprehensive way. There will be a situation where you cannot do that in a comprehensive way. You have to break it down and then add them together. This is another way of doing it. And that again depends on how many problems we do and what kind of situations we deal with, and then we take a call. Is that okay so far? Now, let's look at a little more interesting problem. But before we assume that whatever teacher is going to say is interesting or not, let me see whatever we have talked about so far, is that clear to everybody or not? Adya, Hiranya, Dikshita, Urvi, Myra, Nehan, everybody?
Yes, sir.
Everybody clear? Abhi clear? Okay. Okay, Suhina, Rihan, everybody clear, right? Now, let me give you guys a situation that Tasvik here. Tasvik is beautifying his nails when I'm teaching math, okay? That beautification can be done after the class also. Alright? Let's come back to the class. So if I'm saying I have 3 coins. That is not my entire wealth for you to laugh at, okay? I have 3 coins. I'm tossing the 3 coins. What is the possibility of getting 2 heads and 1 tail? That question cannot be an airy answer, okay? Cannot have an airy answer. You have to solve it for sure. No airy answer. Do it. If somebody is telling me that, okay, I'm tossing 3 coins, what is the possibility of getting 2 heads and 1 tail? And that will not work. Yes, I mean.
So you would take it and then divide it, like so you would take 3 and then divide it by 100.
No, I'm saying what is the probability of getting 2 heads when I'm tossing the coin 3 times? Okay? Or tossing all 3 coins 1 time, whatever it is. Yeah.
A 1 in an 8th chance.
1 in 8 chance. Okay. Lach, what is the answer? What do you think?
The total number of events is you want 2 heads over the total events, but you're flipping 3 coins, so it's 2 over 3.
No, not that straightforward. Yeah.
How many coins did you want to get?
1 coin tossed 3 times or 3 coins tossed 1 time. Both ways are okay because I'm not really. Yes, Suhina.
1 over 3.
I'm sorry, Vita. One more time.
1 over 3.
I'm saying 2 heads and 1 tail.
Oh, 2 over 2.
Okay.
1 over 2.
Well, I don't think it'll be that quick. You guys are not exploring your drawing or what do you call scribbling skills. Yes, Arihan. Go ahead. You have been blinking over and over again. Yeah, go ahead.
Wait, so, 25%?
Okay, but I don't think we are thinking enough. Yep. Half. Okay. Everybody, see, that's what is happening here in the class. All of a sudden, one child will say, half? Then somebody says, 30%. 30%? That reaction reminds me of the serious I used to watch on Doordarshan when I was in India, much smaller, maybe your age, a little older than that. 30%? Yeah. Okay. Somebody raised hand. Now, okay, guys, here. Now teacher saying here, turn. Okay, here we have 3 coins. 1 coin, or let's not say 3 coins. We have 1 coin. We are tossing 3 times. Okay. Now let's look at what the possible options we can get. We are talking about 2 heads and a tail. First time I can get a head. Second time also I can get a head. Third time also I get a head. That is one possibility. Okay. Let's say my head remains fixed for the first toss. Then I get a head. This is another possibility. I still got a head. In the second toss I got a tail. Then I can get a head. So basically I kept the first position fixed and I juggle between head and tail. No, not that juggling. That is a useless juggling that you can do. Don't do that. And then I can get a head in the first place and then a tail in the second and third, both the tosses. And again, it doesn't need any intelligence. You're just thinking about all possible options. Okay? You have three tosses. First toss, let's say I'm getting all head in the first toss. Then my second could be head or tail, tail or head, tail or tail. Okay? Yeah? Now, likewise, if my first toss is tail, I can get a head, tail. It will repeat actually. You will see that first one is tail, then head, tail, head, tail. Okay? There are the 8 options, 8 possible combinations of head or tail you can get by tossing your coin 3 times. What was my question? What is the possibility of getting 2 heads and a tail? Mark the ones which has 2 heads and a tail.
Oh.
How many options we got? 1, 2, 3, 4, 5, 6, 7, 8. And how many of them have 2 heads and a tail? 3 out of 8. So what does probability definition say mathematically? probability is total number of occurrence of an event of that particular event that is in question, which is 1, 2, 3, divided by total number of events 1, 2, 3, 4, 5, 6, 7, 8. And for each one of us to get to this answer, you need to be playful enough. Tossing a coin is a fun activity. It has nothing to do with math. That fun we are putting in the form. Yes. I'm sorry? What is what type of? What type of coin? Very intelligent question, not needed. Okay? For people who are actually serious about what they are doing in the class, you will find that okay. Done? Okay. So guys, let's be respectful and mindful of the time that we have. Okay. Last year saw the watch immediately. So coming back to this one, I'm sorry if I'm making some postures here. That is just to relieve my stress. Okay, because this is my third hour standing in this position. Okay. So go ahead, Abhi. So here, what I was saying was that if you are talking about probability, only thing that you have to keep in mind is probability of any event is represented mathematically by saying that probability of that particular event divided by total number of events. And here, in this situation, or whatever problems we have dealt with so far, what did we do? Okay, how about what is the possibility of getting a number 2 or number 5 by rolling a dice? Okay, so, okay, probability of getting 2 or 5. What is the total possibilities? 1, 2, 3, 4, 5, and 6. I can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Question is, what is the probability of getting 2 or 5? So both are counted. So we are talking about two possibilities, two of the events that is in question, divided by total number of events, which is 6. 1 over 3. So as long as you keep this in mind that what is the probability of me passing the exam? Let's say I appeared for the exam, me passing the exam with only 20% preparation. Only 20% preparation. Dang! Dang has nothing to do here in the class. The dang has nothing to do in the class. What I'm saying here is, it's a question asked. My exam days are over, trust me. Very intelligent. Not needed. So coming back to the point is, anything, but I said that what is the probability of me passing the exam with 20% preparation? I said with 20% preparation. I've done only 20% of the preparation. Now, you guys did not hear the question completely and then started exploring your, what do you call, that sense of humor, which is not needed at times, right? So here, what is the probability of passing? Probability of passing, let's say pass marks is 30%. Somebody gets 30%, passes the exam, let's say. What is the probability of me passing with 20% preparation? If I have to study 10 chapters, I studied only 2 chapters. What is the probability of me passing the exam? So, no, guys, you guys are diverting or misusing or abusing your energy and concentration for something which is not needed right now. Fix your problem first. Take care of your own house before you bother to clean your neighbor's house. Yes? Okay? So coming back to this one, guys, trust me, this is not funny at all. This is not funny. This is going beyond my threshold where I will start blasting. So stop there. Stop. Stop there. Stop there. You too. You too. I'm being very serious. I'm saying that I'm trying to make you guys understand a question. You're trying to explore sense of humor in that question, which is not needed. Do you think by laughing in the exam you'll get 100%? Then why are you wasting your energy for laughing right now? You can laugh after the class also. Nobody's stopping you from doing that. And if you're seriously not able to control your laughter and you have smelled enough laughing gas, N2O, go and vent it out outside. That's why we had an opportunity, in our younger days, to vent it out by converting to a chicken during the class hours. You're in the class and you are laughing. Advik, you are in the class and you are not paying attention. Teacher will say, okay, you are not a child right now. For next 2 minutes, you translate, convert into a chicken, and then they'll become chicken. And if you don't know how a chicken looks like, see on YouTube. You will see how people used to, how the teachers used to make kids like chicken.
Yes.
Okay. So guys, Advik, what you are doing is also equally bad. Okay. If I'm trying to control fire, I have to cover the fire, not expose the fire to control it, right, or contain it. So that's what. All right. So we talked about what is probability, how do you mathematically define probability, and how do you solve some basic problems. Now what I've done is I have put some questions here. Okay. Whatever questions we talked about so far, those are the things that I did on the fly. Now what we are going to do now is we'll look at some legitimate problems that you guys will deal with in your grade levels and see if whatever we know, how we are going to apply that for solving it. Is that okay, Adya, Saurya, Deekshita, everybody? Yeah. Sami, Suhina, they keep interacting with me more often, even Lach. So that way, even Arihan. Some of you, when you stay quiet, right, that is where I kind of get little worried at times. So that's why I will keep asking or calling out names. It's nothing to do with putting anybody on the spot. It's about making sure that whatever we know, we are able to apply that. Okay, now my bad, you're bad, my neighbor's bad, Mr. Trump's bad, everybody's bad. Okay, attention back. Mr. Darvish has a class of 5 students for reading intervention. I'll repeat the question again. I have the habit of repeating, don't worry about it. Mr. Darvish has a class of 5 students. Mr. Darvish has a class of 5 students for reading interventions. At the beginning of every class, Mr. Darvish picks a student randomly to tell the class a reading fact they know. Guys, we had a leak of laughing gas in the classroom, and Arav has not been able to control his emotions post that. I will do some research in YouTube tonight to figure out if somebody gets affected by laughing gas, what is the remedy for that. And I'll probably try finding a home remedy or organic remedy so that at least, I'm being serious, okay, I'll find out. If you're not able to control your laughter when you're not supposed to laugh, is there a way? Maybe I'll say, okay, recall one god or pull one hair from your ear, from your head, whatever.
There's one.
Okay, no. If you know one, why are you not applying it? Then your knowledge is going waste.
You took it away.
Arav, am I actually here for listening to all the unnecessary stuff, or only for figuring out how to control your laughter and be totally ignorant of everybody's time? Everybody is waiting for me to teach something. Okay. I am hoping that I don't want to repeat myself. It is not right. Let me read the question one more time. Mr. Darvish has a class of 5 students for reading intervention. At the beginning of every class, Mr. Darvish picks a student randomly to tell the class a reading fact that they know. The students and their grades are listed below. Somebody with name Kara, 7th grade. And don't rush to conclude anything. I'm still writing it. I'm still not myself sure what the question is all about. And then we will decode that further before we try solving it. But don't get tempted to talk. And it's not only about Arav, it's about everybody else who has to contribute for maintaining the the discipline in the class. So Advik, if you think that it's always Adam only, that is not right. If somebody is not able to control it, you make sure that you're just ignoring it. You're not becoming a partner in crime. Okay, I'll probably not go to this problem. This is little too basic in nature. It has very stupid question to ask, but we'll come back to this, okay? Let's not look at this one. Let me give you guys something that you can relate to easily and we can solve few problems. You roll a fair six-sided die. You roll a fair six-sided die. What is P? What is P? Roll has less than 4. Less than or equal to 4. So you are rolling a die, a six-sided die, not the die that you use for coloring your head. That's why I don't dye my head. So coming back to this one, again, don't find any funny fact to it. There's no funny fact to it. Okay, we're not talking about fake news also. We're only talking about a mathematical problem. Okay, you roll a fair six-sided die. What is the P, meaning the probability that roll has less than or equal to 4? Don't jump always, that's not needed. But why I have to keep on repeating myself? Am I mad or you are wanting the class to go mad? Who is stopping, who is prohibiting you from making use of your pen? How much money you can save by not writing on a notebook in next 5 years? Every day you are saving 2 cents. Next one year you will save 30 cents. 5 years you will save 36.50 cents. That is $36.50. Is that enough motivating? Is that motivating enough? Find a better teacher. Okay. Yeah. Did you guys hear the question? You're rolling a fair die, six-sided die. What is the probability of getting a number lesser than equal to or equal to 4? Yeah. 2 by 3. Okay. Yeah, Gayatri.
2 by 3.
Lux.
2 by 6, which can be simplified to 2 by 3.
Okay. Was this easy peasy for everybody? Yes, sir. Yeah.
So I was going to say
2 by 3, right? Everybody says 2 by 3. So this was more like to get rid of the laughter gas. Let's look at a serious one. This will test our understanding of probability in a little better way. Let's look at this one. Somebody owns a farm. She is going to randomly select one animal to present at the state fair. She has 6 pigs, 7 chickens and 10 cows. What is probability of getting a chicken? Arab, not funny. Seriously not funny.
How many would be Jim more there?
I'm reading the question one more time. Somebody owns a farm. She is going to randomly select one animal to present at the state fair. She has 6 pigs, 7 chickens and 10 cows. What is the probability it's a chicken?
10 cows?
With 10 cows?
6, 7, 10. 6 pigs, 7 chicken, 10 cows. Yeah, Rihan, you raise your hand.
Not on accident.
Okay.
So can you repeat the last part of the question again?
Okay. Hands down. I'll come to you. No, not you, beta. There was somebody raising hand here physically. So somebody owns a farm. She is going to randomly select one animal to present at the state fair. She has 6 pigs, 7 chickens and 10 cows. What is the probability? It's a chicken. Did you hear it? Yep. Yeah, Arab, go ahead.
Oh, 7 by 2 to
7 by 23. Okay, yeah, lunch.
6, 7 chickens.
I was gonna say the same thing, 7 over 23.
I'm sorry?
I
Lunch?
was gonna say the same thing, 7 over 23.
Okay. Okay. Yeah.
7 over 23.
Yeah.
10 by 23.
And Arab, that 6, 7 has to stay out of this class. That 6, 7 has to stay out of this classroom. I'm being very serious. No, that's not funny. Do you want me to talk to daddy after this class? No, right? That 6, 7 has to stay out of the classroom. Unnecessary laughter. I'm okay you guys being happy about learning math. Doing math in a more fun way, but don't make the class funny. This is not funny. Or this is not funny. I will make sure that I'm not poking into your personal space. I don't want you to get onto my nerves, okay? I'm not dealing with the kids who are roaming around with diapers on. I'm talking to kids who are about to go to high school. So I expect some level of maturity in each one of you, including myself. Okay, yes, Serena.
7 over 23.
Okay, Arihan?
Same here, 7 over 23.
Okay. Sammy?
7 over 23.
Okay. Now let's go to our next problem. Yeah, there.
Yeah, 7 over 23.
It's simple, right? I mean, there's nothing complicated about it. Myra, how about you? You're opting to stay quiet?
That's what 7 over 23.
Okay, 23. Okay. So it's simple, right? It says you have, the person who's going to plan to pick one animal to take to the state fair, she has 6 pigs, 7 chickens, and 10 cows. Total number of animals that she can pick from 10 plus 6, 16 plus 7, 23. How many are chickens here out of that?
Those are cows.
Oops, sorry. 7 chicken out of 23. So probability of chicken is how many chickens? 7. You can pick chicken 7 ways. Out of how many ways you can pick up? 23. So that is your probability. Yeah, yeah, already got your answer, yeah?
Can we see the one with like the 5 children or something?
What is that?
The one with like the 5 children and the different grade levels.
So there are different problems that we can solve. We just started with probability. So I'm not going to finish probability in one class. We are going to do more problems. We have just touched some of the basic concepts. Now, how do we go to the next level? That will depend on how effectively we are using the class. I'm wasting a lot of unnecessary time teaching things that I should not be. Now I don't know who's getting the message or not. That's for everybody, okay? Whoever is misguiding the class, whoever is creating any disturbance in the class should get this message that we should not do things that is waste of time for everybody, okay? Now I'm sure this is not only me struggling with this, it's a problem with the age. And every teacher has to go through this. But I don't care about other teachers. I'm here, I have to make sure that every time you guys are here, I'm able to do justice with your parents' time. your effort and my time too. Let's look at the next problem before I let you guys go. You draw a card at random from a deck that contains 3 black and 7 red cards. You have a pack of cards. You pick up a card at random that contains 3 black and 7 red cards. What is the probability of getting red? Let's say you have 3 black and 7 red cards. What is the probability of getting a red? And what is the probability of getting red in the first go and black in the second go? So this question has 2 parts to it, and I'm tweaking this question a little bit so that I set the tone for what we're going to cover in the next class. So we have a pack of cards which has 3 black and 7 red cards. When you randomly pick one card, what is the probability of getting a red? I'm pretty sure you guys know how to do it. Now I'm saying, okay, now from the same pack of cards, I will pick the card twice. First time I'll keep that card aside, and then make another pick from the same pack. So I'll get 2 cards. So what is the probability of getting a red in the first go and a black in the second go? So I'm looking at a combined probability. After you help me solve the first one, we'll look at the second one, and I will not tell whose answer is right or wrong, but we are just setting the tone for the next class. Yes?
So where the red one got 7/10, and for the second one I got 1/4.
Second one you got 1/4, so 7/10 for the probability of getting a red. So 7 out of 10, okay? Yeah, Lach. So 1/4, you got second.
The possibility of pulling a red card in general is 7/10, and for the second one, the possibility of pulling a red one first try and a black one second try is 1/4, 1/4.
Okay, we'll come to that. I would want to hear that from you guys. Yes, Ami.
So for the first one, I think it would be 7 out of 10. And then for the second one, I think it'll be a 50-50 chance.
Okay, let's see what Abhi has to say.
Never mind.
Yeah.
Never mind.
Okay, no worries. Suhina.
For the first one, it's going to be like 1/7, and
One.
the second one,
1/7 or 7/10?
7/10.
Yeah.
I wrote my notes. So I have to find my notes. And then my second one is like a half.
Okay,
It's like 2 or 1 or like.
I'll come to you. Okay. Yep.
For the first go, it would be 7/10, and for the second one, I think it would be 1/3.
Okay. So let's see what is the answer I'm getting from Urvi, Adya, Milona, Deechita. And when I'm calling out names, the goal is to make sure that everybody is with me, okay? I'm not making anybody sleep here in the class. That's the main goal. So Urvi's, Adya's, Saurya, Suhina. No, Suhina has given the answer already. Vasundhara also. Yep. Tell me what's going in your mind, beta. It's okay. Yeah, Rihan.
I got 70% for the first one and 50-50 for the second one.
How much?
50-50 for the second one.
50-50. Okay.
Like 50%.
Okay. How about Deekshita? Yeah, go ahead.
first one I got 70%, and the second one I got 50-50.
50-50. Okay. Sami, you want to say something? Okay. Milana.
I got 70% for the first one and 50% for the second one.
Okay. I'll come to you. I mean, let everybody speak up. Urvi, go ahead.
For the first one, I got 70%, and then for the second one, I got 50.
Okay. Yeah.
For the first one, I got 7 out of 10. For the second one, I got
1/3. Now, lunch. Aryahi, any thoughts? No? Okay. Little confused? Okay. First one is no problem, right? And see again, it's okay. I want kids to tell me that, okay, I'm not clear about this. And that's what we are here for, right? Let's make sure that we are using the class for the right reason. So Aryahi here, and Adya and Lasya. Did I say it right? Yeah, okay. So, are you guys first clear about what is the first question? Mm-hmm. That part is okay? Now, second part of the question was that, okay, I have a pack of cards with 3 black and 7 reds. That is 10 cards. What we are doing is, first one is done, okay? You picked one card and what is the probability of getting a red? Now, the extra tweaking that I have done to the question is that, let's forget about this scenario. This is, okay, one card being pulled and that being red is 7 out of 10. That's okay, 70%. What if I'm pulling 2 cards? First, 1 card, keep that aside, then second card. And there is a sequence in which it has been asked. So, okay, fine. What is the probability that my first pick is red and my second pick is black? How do you derive that thing? And I have not taught you guys anything. I'll just give 1 minute to Laksh. You are the first one to talk about that. Tell me, how did you arrive at 25%? One more time, beta. One more time.
What do you say?
No, I was saying just repeat it one more time. I could not hear you.
I did like options of what chances of what is the first one, the second pull, and there's only 4 options, and one of the options where first is red, then it's black, so that's 1/4.
Okay. I'm not even talking about that. So, Aryahi, you heard something. I have not taught anything. I don't know about it yet. It's okay. It's fine. He said something, but I'm not justifying or defending it. It's already time for us to get the class over. I will. Yeah. You were saying something. Yeah. Tell me. How did you arrive at your answers?
Oh, basically, I listed all the probability in it so that I was going to it.
Okay.
Can I say how I got So first I did like the 7/10 for the first one. And so after we had the first card of the red, I subtracted 7 minus 1, so we got 6 cards left. And so I did the same process for black, except it was 3/9, which got me 1/3.
Okay. So, but see, first you have to look at these 2 events together. It's not about my first event is done, and then whatever comes for picking the second card, which is 3/9, that is not my overall probability. I have to look at these 2 things together. That's what we're going to talk about. That is what is called combined probability concept that we'll have to talk about. So it's not just about car on the road. So that is what kids are doing here. I'm saying that don't bother. Pay attention, we're almost done. So what I was saying was, you don't have to look at this probability and this probability in isolation. This becomes a combined probability. What is the probability of getting a black in the second attempt when my first attempt has gotten me a red? So when you're looking at these 2 probabilities combined, how do you arrive at that? That's what we're going to talk about in the next class. Till that time, have fun and watch less number of Indian serials because that creates that extra reaction, not needed. Alright, have fun. Bye bye, bye bye, bye bye, bye bye. Bye bye. Bye bye.